Hello everyone, welcome to Brain Blitz Audios. Today in this episode of JEE Main, we'll be looking at previous year questions of mathematics asked in engineering entrance exams in India. Today we're going to be looking at a very important chapter which is asked in previous year questions of engineering exams. The chapter is Integral Calculus. Now this chapter deals with integration and the various forms of integration and how do we apply integration in daily life. So without further ado, let's look at our first question for this episode. In this question, we're asked to find the integral of the greatest integer function of x squared from the limit 0 to root 2. So how do we solve this question? This question was asked in 2002 and it's actually quite simple, but we need a slight different perspective into it. Now notice that the square bracket here represents greatest integer function. So the greatest integer function is a function which has the value of the lowest integer in a particular series. So say you have a series from 0 to 1. So if you have a value, say 0.5 inside the greatest integer function, the value of that function will be equal to 0 because 0 is preceding that number. So for the range 0 to 1, the greatest integer function x is equal to 0, and from 1 to root 2, the greatest integer function of x will be equal to 1. So when we look at our integral, that is integral 0 to root 2 greatest integer function of x squared dx, we can write it in two ways. We can separate it into two integrals. So the first integral will be from 0 to 1 and the greatest integer function dx, plus the limit is from 1 to root 2, and then the greatest integer function is now addressed again. Now as we noticed, from 0 to 1, the value of the greatest integer function will always be 0. So therefore from the limit 0 to 1, the value of the greatest integer function is equal to 0. And for the next half, that is from 1 to root 2, the greatest integer function will always show a value of 1. So you can write 1 dx. So basically you have integral of dx from 1 to root 2. So integral of dx is x. So that is x with lower limit 1 and upper limit root 2. So you get root 2 minus 1 as the correct answer for the integral greatest integer function of x squared from 0 to root 2. So the right answer for this question is option C, root 2 minus 1. And this we have understood by having a basic idea of what the greatest integer function does and the possible values, and then using simple integration we got our final answer. Now let's look at the next question. The next question is asking us to find the integral of mod of sine x dx from the interval pi to 10 pi. So these kind of questions are a special type of questions because for one thing we have a periodic function, and in a periodic function there is always a period which we can represent generally as a. So for a periodic function f of x with period a, you can write that integral of m a to n a, and the function is f of x dx, can be written as n minus m times integral 0 to a f of x dx. So on using this property over here, fx is mod sine x, and the period of mod sine x is equal to pi. So therefore the above question, that is integral pi to 10 pi mod sine x dx, this can be written as 10 minus 1 times integral 0 to pi mod sine x dx. So 10 minus 1 is 9, and the integral of sine x is minus cos x. So you can add a so you can put the minus before 9 or after 9. It doesn't make a difference. So minus 9 into the integral of sine x, which is cos x. So the integral of sine x is actually minus cos x. The minus is taken out, and it's taken from the interval 0 to pi. So cos of pi is minus 1, and then you have an automatic minus, and then cos of 0, the value is 1. So minus 1 gives you minus 2, so minus 9 times minus 2. So the value of integral pi to 10 pi mod sine x dx is equal to 18. So whatever units it is, the value of that integration is 18. So if you look at our options, you can see that option B is the correct option for this question asked in 2002. So over here, it's a simple property that we use, the property that states that if you have a periodic function and the limits correspond to some value involving periods, then it will be n minus m times 0 to the first period and then f of x dx. So this is what we used to solve the question right here. Now, I've made a mistake right here. So instead of writing 18, I've written that for 8. So the right answer is option D, which is 18. Because if you look, you'll know that our correct answer that we've calculated is 18. It was just an oversight. So the correct answer for this question is option D, 18. Now, let's look at the next question. This question states, if y equals f of x makes a positive intercept of 2 and 0, unit x and y, and encloses an area of 3 by 4 square units with both the axes, then you need to find the value of integral 0 to 2 x times f dash x dx. So how do we solve this question? Now, we do not know how the shape of the graph is for y equals fx, but what we do know is that the origin of the Cartesian plane occurs at 0, 0, and the positive intercept of y equals f of x is at 2, 0. So the area of y equals f of x can be calculated from 0 to 2. And in the question, encloses an area of 3 by 4 square units with the axes. So this statement is referring to the fact that integral 0 to 2 f of x dx is given as 3 by 4 square units. So the integration of the function f of x from 0 to 2 gives you 3 by 4 square units. You need to find out the value of integral 0 to 2 x times f dash x dx. So for this particular question, we're going to use integration by parts. So in integration by parts, the best way to remember it is to use this simple mnemonic fis minus id fis. So f stands for the first function, is stands for integral of second function. Here minus, we have a minus, sign. Then we have a big integral. After that, we have a derivative of the first function and integral of the second function, followed by the dx for the large integral. And the order for this sort of arrangement for integration by parts, we have a specific order. Inverse is given priority. Inverse functions are given priority, then logarithmic, then algebraic, then trigonometric, and finally in the end you have exponential functions. So now for our given question, that is integral 0 to 2 x times f dash x dx, we know that both of these are algebraic. So what we're going to do is we're going to take the same order. So when you're integrating by parts, first function, we write it as it is, minus the integral of the second function, times the integral, so multiplied by the integral of the second function. So that is integral f dash x dx, and then minus the huge integral. Then we write the derivative of the first function times the integral of the second function, that is f dash x dx, and then put this in a bracket and write a dx for the larger integral. Now this is the scenario when you do not have limits, but in this question we do have limits. So when you are having limits, it's important to note that the FIS part will have a limit across all of the terms. So the first function and the second function both have limits. And for the second integral part, that is IDFIS, you will only have the integral across the larger integral. So the first large integral gets the limit, the integrals and derivatives inside it don't. So this is how you represent integral 0 to 2 x times f dash x dx. So when you look at it, you will find that x times integral of f dash x. So since the integration is also known as antiderivative, so the antiderivative of a derivative of a function gives you the function itself. So x times f of x from 0 to 2 in the first bracket, and then if you take minus, and then in the integral from 0 to 2, dx by dx is 1. Integral of f dash x dx, that gives you f of x. So f of x dx. Now integral 0 to 2 f of x dx, we already know the value of the second part. It is 3 by 4, and you can write 2 times f of 2 minus 0 times f of 0, just putting in the limits for the first part, and then minus 3 by 4. Now over here we should note that f of 2 will be equal to 0 because this function is having a positive intercept at x equals 2. So f of x, the function at x equals 2 has to be equal to 0 because of the positive intercept. So therefore it'll be 2 times 0 minus the right side will be already 0. So the actual value of integral 0 to 2 x times f dash x dx is equal to 0. There is no 0 actually because there is also minus 3 by 4, so it is basically 0 minus 3 by 4. That is equal to minus 3 by 4 square units. So in integration, it's very important to be focused because sometimes many details are there and that can deviate your focus. So over here, 2 times 0 is 0 minus 0, and then there's a minus 3 by 4 which is already present. Do not forget that. So 0 minus 3 by 4, that is minus 3 by 4 square units, gives you the correct answer. So the correct answer of 0 to 2 x times f dash x dx is option, in this case it's option D, that is minus 3 by 4. So for this question asked in 2002, it's important to use integration by parts and also to use data from the question in order to make your life simpler. So having said that, let's look at the final question for this episode. So the area of the region bounded by the curves y equals mod of x minus 1 and y equals 3 minus mod of x is. So let's first draw the graph on, let's say, this side. So you have a vertical and a horizontal axis, x and y preferably, and you have y dash and x dash here. So now you have the first curve y equals mod of x minus 1. So this gives you an idea that at x equals 1, the value of y is equal to 0. So you'll have this curve representing mod of x minus 1. And then you have y equals 3 minus mod x. So that means at 0, 3, so that means at x equals 0, you will have y as equal to 3, so 0, 3. And then this vortex is 1, 0. And you will have these joining points. So we need to find the values for those. So what we do is we take y equals mod of x minus 1 and y equals 3 minus mod of x. So over here you just need to compare. So on comparing, you notice that the left hand sides are equal, so therefore mod of x minus 1 is equal to 3 minus mod of x. So in this scenario, we're going to have two cases. In the first case, x is less than 0. So when x is less than 0, the modulus value will be negative. So minus x, since x is positive here, it has to be negative, and minus 1 is present inside the modulus, so it gets converted to plus 1 due to multiplication by minus. So minus x plus 1 is equal to 3 minus the modulus value becomes negative, so minus x. So therefore you have minus x plus 1 equals 3 plus x. So therefore you have 1 minus 3 as equal to 2x. So that means 2x equals minus 2. So when 2x equals minus 2, that means x is equal to minus 1. So at x equals minus 1, you will have the value of y. Let's put in the easier function, which is mod of x minus 1. So y is equal to mod of x minus 1 is one of the functions given here. So instead of x, we'll put minus 1. So minus 1 minus 1. That means you get modulus of minus 2. Modulus of minus 2 will be equal to 2. So therefore, at x equals minus 1, y equals 2. So if you look at our point here, this will be that point. So minus 1, 2 will solve one of these points. The other point we have to solve right now, so for that we'll take x greater than 0. When x is greater than 0, you will have x minus 1 equals 3 minus x. The modulus values are now positive. So therefore, 2x will now be equal to 3 plus 1, that is 4. So therefore, x equals 2. So at x equals 2, you will have y equals mod x minus 1. So that is 2 minus 1, which is equal to 1. So therefore, you will have 2, 1 as the other point of intersection between the two curves. So now that we've found the intersection, we will draw a number line. So in this number line, we're going to divide the number line into basically 4 points. So you will start from minus 1 over here. So it will be minus 1, and then you have 0, then you have 1, and then you have 2. This is in accordance with the graph given here, because over here so we're taking the vertex as our interval. So over here the x value is -1, and then you have 0, the origin coming in between, then you have 1, the vertex of the curve y equals mod of x minus 1, and then you have 2, 1 where the two curves meet. So therefore, using this, you will get for the first for y equals 3 minus x, 3 minus mod x, you will get a negative value first, then you will have a positive value, and again a positive value. For y equals mod of x minus 1, you will first have a positive value, then a negative value, and then we have a positive value, and then finally we have a negative value. So for each of the intervals, this is the symbol, this is the sign that goes along with the function, so the function changes accordingly. In a modulus function, the sign becomes very important, because if it's plus, then it stays as it is. If it's minus, you have to multiply -1 to the entire terms. So having said that, let's look at the required area for this scenario. So now the required area is taken along the x-axis. So we'll take the points from the x-axis as our reference. So first is -1 to 0. This was the first interval, and in this interval the second curve is negative, so 3 plus x, and the first curve was positive, so that is x minus 1, and then dx. And you add the area of the next interval. The next interval is from 0 to 1, and from 0 to 1 the curve is now changing, because the second curve becomes positive, and the first curve, it also becomes positive, and then you have dx. And finally, for the third interval, that is 1 to 2, you will have the second curve becoming positive, and the first curve undergoing negative values, so that is -1 time, basically it's plus, but then the value that we put in is x plus 1 instead of x minus 1, so that's why it's shown as negative. And then you will have dx as well. So this is the equation for the required area. So all of these are separated by plus and minus, so therefore on integration you will have 3 times integral -1 to 0. Instead of doing that, we can just combine the functions inside the brackets, so you'll get integral -1 to 0, 3 minus 1 is 2, x plus x is 2x, so 2 plus 2x times dx, plus integral 0 to 1, and then now you'll have x plus x gives you 2x, and now it will be, so in this scenario what basically happens is that over here it becomes negative, because this part also becomes positive, so minus x plus x gives you 0, 3 minus 1 gives you 2, so integral 2 dx. And then the final integral from 1 to 2, you will have 3 plus 1 is 4, and minus x minus x gives you minus 2x. The reason why minus came there is because the negative part of that, since the modulus is x minus 1, when it's negative, it will be minus x plus 1. That was how we used to solve it to find those 2 points. So now that we've got it this far, we can now integrate separately. So it'll be integral minus 1 to 0, first it will be 2. So 2 times integral of dx is x, and then from minus 1 to 0. Then plus you have 2x, so 2 times integral of x dx is x squared by 2, so 1 by 2 is taken outside. Inside the bracket you have x squared. The limits are minus 1 to 0. And then you have 2 on the outside. Integral of dx gives you x. This is from 0 to 1. And then plus you have 4 times integral of dx is x from 1 to 2. And then minus 2 times 1 by 2. You will have integral of x dx is x squared by 2. So 1 by 2 is taken out. And then the limits are from 1 to 2. So now let's put in the values. So 2 times 0 to minus 1. So basically it is 0 minus of minus 1 plus 2 times, here it's a square, so it's 0 minus 1, because minus 1 square is 1. Then you have 2 times x from limit 0 to 1, so that is 2 times 1 minus 0. And then plus you have 4 times 2 minus 1. And then you have minus, so over here the 2 gets cancelled by 1 by 2, so therefore there is nothing. So now you have what we call minus 2 by 2 times x squared from 1 to 2. So that means x squared from 1 to 2, that means it'll be 4 minus 1 inside the bracket. So 0 minus minus 1 is 0 plus 1, that is 1. So 1 times 2 is 2. Then 0 minus 1 gives you minus 1. 2 times 1 minus 0 gives you 2 times 1, that is 2. 4 times 2 minus 1 is 4 times 1, that is 4. Then you have minus 4 minus 1 gives you 3. So now you have minus 1 minus 3 gives you minus 4. Then you have a plus 4. Then you have 2 plus 2. So these 2 gets cancelled. 2 plus 2 gives you 4. So the right answer is 4 square units. Therefore, the correct answer to this question is option B, 4 square units. This question was asked in 2003, and it shows the extent to which we have to integrate in order to get the correct answer at times. So that concludes this episode of JEE Main. We hope you found this episode interesting. For more questions on application of integrals and integration, you can always go to our channel www.youtube.com/ce/brainblitzaudios. For getting more of our videos on JEE Main, you can always hit the link in the description down below. And for getting more of our useful and interesting content, you can subscribe to our channel. Don't forget to subscribe it only once to the channel that is Brain Blitz Audio. So until the next webisode, take care, stay safe, bye-bye for now.